Today, for the third year, first semester, as per the JNTU Anantapur syllabus, this is the topic of networks, signals and systems. So, this is about the lectures of the networks, signals and systems. So, before going to this, the deep part of the network, signals and systems. So, first of all, there is the 5 units must be there. Under this, the first unit, there is the network elements and sources. And what about the different types of the elements? That means under the linear and non-linear elements and the distributed and the lumped parameters and different types of how this resistive networks must be analyzed. And coming to the next unit, that is the two-port networks. Under this two-port networks, what about the different types of the parameters must be there, like that means a short circuit parameters, or it will be the open circuit parameters. And from that, not only that parameters, there is the H parameters, and we have taken as the ABCT parameters, but in your point of view, there is the short and open, and depend upon the short and open, it may called as a Z and Y parameters. And then there is a what about the locus diagrams, and what about the driving point impedance functions, and what about the two element synthesis source. And coming to the next point, there is about the third unit, that is introduction to signals, and what are the different types of the signals, and what are the Laplace transforms, and what is the frequency response, and go to about the Bordeaux plots, how you find out the poles and zeros. And then next, coming upon the graph theory, and that graph theory, what are the basic definitions of the graph theory, and what about the Z parameters and Y parameters, and under the graph theory, there is the Cut-set matrix, tie-set matrices, and incidence matrices. What are the, and what is the image impedance and iterative impedance, and what are the different RLC two-terminal networks. This upon the fourth unit. And fifth unit, there is the synthesis of network function. Under the synthesis, what is the network, different parts of the function, that is what are the main synthesis of the two-port network, and what is Fourier series and Fourier transforms. So about this 5 units, what are the best outcomes you have to there? So what is the network, and how you find out the equivalent impedance by the concept of two-port network, and to analyze the frequency response of electrical network using Laplace transforms, and by applying this Fourier series to simplify how the network will be simplified by using this by simple concept of the Fourier series, and how you synthesize the networks using the different network functions. For this network elements and signals and systems, for first you have to introduce the first unit, that is upon the in the first unit, these are the contents. So under this first unit, that is the terminologies in the network analysis, and what are the different types of elements and sources, and what is linear and non-linear element, and what is distributed and lumped parameters, and what are the different network analysis, that is the under the network analysis, how you find out that mesh analysis, nodal analysis, and source transformation method. And next we're going to the star delta transformation. So these are the some of the total contents in your first unit. So that is that when you go about the terminologies in the network, that means what about the current, what about the voltage, what is the power, what is the node, what is the branch, and energy, what are the different, what is the circuit, what is the circuit. These terminologies, basics, the some of the definitions must be there. And when you go the types of the elements and sources, there are the actual give, we know that there are the two types of the elements must be there, that is the active elements and the passive elements. From that elements, there is the active elements, or there is the sources must be there. So from the sources, there is the ideal voltage source, and ideal current sources are there. And coming to the linearity and non-linearity elements, that means depend upon the networks, there is the classification of the network elements are there. Under the classification of the network elements, we know that there is a time variant, invariant element, and lumped and distributive element, and unilateral and bilateral element, and time variant and invariant elements. And coming upon to the next topic, that is the network analysis. Under that network analysis, when you have to find out the network in different forms, there is a mesh analysis must be there, or nodal analysis must be there, and there is the star delta transformation and source transformation technique or this. These mentioned the nodal analysis, it is also called as the KVL, we have to tell that, and KCL we have to. These are the some of the contents in your the first unit. And then coming to this general terminology, we all know that this is of the simple electrical circuit must be there. So what is the circuit must be there? It is a closed path followed by an electric current is nothing but the electric circuit. That means in this circuit, we know that all there is the load must be there, and there the connecting wires must be there, and battery must be there. We have to connect a battery to the load, or that means any bulb to the wires. So this is a closed path followed by an current is nothing but the electric circuit. That means here when you see this figure, there is a battery is there. So here the battery will be the delivering the power, that is the active element, and the remaining inductor, resistor, and capacitor must be there. These are the passive elements are there. That means these are the receiving elements. So this complete active element and passive elements, the combination of the total part is nothing but the electric circuit. And go to the some terminologies of this next one is some of the definitions. We all know that node. A node means it is a connection of two or more elements. So that means if there is a two branches must be there, or three segments must be there, we have to connect. Already I mentioned some arrows, there is the node must be there. So two or more elements meet at one point is nothing but the node. That means if suppose elements is nothing but a line segment joined between the two nodes is nothing but the branch or element must be. So there is two or more elements meet at one point is nothing but the node. When you take the branch, here the branch is the connection of connection of between the two nodes. Connection between the two nodes is nothing but the branch. That means the a line segment joined between the two nodes is nothing but the branch. These are the some of the definitions of one node and the branch. And next one, there is the different definitions must be there. We have there is the charge, current, voltage, and power, and the energy must be there. So when you take about the charge is nothing but the quantity of electricity that flows in a given time. That means the somehow what are the quantity of electricity that flows in which the given time is nothing but the charge. Generally, we know that charges may be a positive charges or negative charges must be there. So whenever the like charges repel each other, unlike charges will be attracted each other. Generally, this charge, the word we have to use is Q, and the unit of this charge is nothing but the coulombs. And next we know that the current is nothing but the it is the rate of flow of charge, rate of flow of electrons. So this is nothing but the current. Generally, what is the word we have to use is I, and what is the unit of this current will be amps. Current will be amps. And then we have taken as the voltage or EMF. So voltage, what is the voltage? The amount of work done to move on a unit charge from one point to another point is nothing but the circuit is nothing but the volts. So it generally the word which we have taken here, it will be V, and what is the unit of this will be volts. And the power, what is the rate of doing work done, is nothing but the power. So for the power, what is the word we have taken is the P, and what is the unit of this power will be watts. And this energy is power with respect to time, that is joules or watt hour. This energy will be mentioned with letter E. So these about the basic terminologies, that means what about the power, what about the time, what about the work, and what about the voltage, current, and different nodes, junctions, elements, and what about the loop. A loop means it starts at one point and return back to the same point, is nothing but the loop analysis. So these are the some terminologies used for this network. I mean, what some definitions must be in this first unit. And then we have go to about the basic circuit elements. Actually, this basic circuit elements, we all know that there are active elements must be there and passive elements must be there. What about the active elements must be there? So active elements are which delivering the power, I mean, delivering the power is nothing but the active elements. And when you take the passive elements are there which receiving the power is nothing but the passive elements. And then from this active elements, there are the sources are there. So active elements is nothing but the sources. Sources means which delivering the power is nothing but the active elements. Under these sources, there are two types of elements must be there. We all know that, that is the generally that is the voltage sources and current sources. Generally, it will be converted as the dependent sources and independent sources must be there. Dependent sources and independent sources must be there. When source will be depend to the another, then it will be called as dependent sources. When one element does not depend upon the another element, one source does not depend upon the another source, then that type of element is nothing but the independent sources. So basically, these sources these sources must be further classified as the voltage source, and the current source must be there. Under the voltage and the current source, there is the dependent sources are there and independent sources are there. So in this voltage source and current source, this voltage source and current source is further classified. So this is the independent sources. So sources must be dependent sources and independent sources. And dependent source means one source will be depend to the another, then it will call as dependent sources. These dependent sources are voltage control voltage source, current control current source, voltage control current source, and current control voltage source. So one will be depend to the another, then one will be controlling by the another source, then it is called as dependent. When you take the independent sources, it will be classified as the voltage source and current source. This voltage source, it is further classified as the two types, that is ideal voltage source and practical voltage source. And the current source, it is further classified as two types, that is the ideal current source and practical current source. So what is the voltage source must be there. So what is voltage source? Voltage source is nothing but whatever the current must be there, the voltage will be maintained constant, then it is called as voltage source, and it is also called ideal voltage source. Why I am telling this ideal voltage source means, if any voltage source, the resistance is in series. In any voltage source, the resistance is in series. So what I am telling in ideal point of view, that the internal resistance, whatever the internal resistance is in series. In the idea, I am telling in the ideal point of view, I have neglected that resistance. That means I have put it will be 0. So I am telling the ideally, that means I am neglecting that resistance, then the voltage will be maintained constant. That means whatever the current will be there. So when there is the practical voltage source must be there. When you take the practical voltage source, in this practical voltage source must be there. That practical voltage source, here I am telling in ideally I am neglecting the resistance, but when you take in the practical point of view, there is no chance by neglecting that resistance. So for that point of view, there is the there is the drop in the voltage drop. So when there is the ideal point of view, it will be constant. When there is the practical point of view, I am telling that there is the drop in the voltage. So then when there is the drop in this voltage, then there is the little variation of this curve. That means when it will be the constant point of in ideal, but in practical it will be the some slope, that is the drop in this. Same thing when there is the current source. The current source must be there. So what is the current source? Current, whatever the voltage must be there, the current will be maintained constant. Then it is called as the current source. Then it is called as the current sources. So in this current sources, generally there is the called as ideal current source and practical current source must be there. So what is ideal current source and ideal practical? So generally I am telling that in voltage source, the internal resistance is always in series. But when you have taken the current source, the internal resistance is always in the parallel point of view. So I am telling in ideal means I am neglecting that resistance. So when I am neglecting that resistance, the current source will be maintained constant, whatever the voltage must be there. So then it is called as ideal. I am telling we have ideally. So whenever it will be the ideal point of view, I am neglecting that current source. So it will be in the constant point of view. When we have taken the practical current source, under the practical current source we have considered, that means there is no chance to neglect that resistance. So we have considered that practical internal resistance will be added. So whenever the internal resistance will be added, there is some drop in the current. So it will be slight variation of this practical current. So whenever in taken of the ideal, it will be constant. When we have taken is the practical point of view, there is the drop. So in the voltage source, that voltage source is always whatever the current must be there, it will be maintained constant. In the current sources, whatever the voltage must be there, you have to maintain the constant. That is called as ideal, current sources. And then we have to take it as a passive element. So passive elements are there, what's receiving the powers is nothing but the passive elements. Under the passive elements, there is the resistor, inductor and capacitor must be there. So, passive elements is the capable of it is not capable for generating electric energy, but active elements is capable for electrical energy. So, under the passive element, there is a resistor, capacitor, and the inductor must be there. When you take the resistor and when you take the inductor and when you take the capacitor, what is the resistor? Resistor means which opposes the flow of current is nothing but the resistor. So, generally, we have to take in the symbol will be R, and what is the unit of the resistance will be O, which opposes the, but the resistor will be time independent. That means it does not store any energy, it is dissipated in the form of heat. That is nothing but the resistor. And then you have to take in as the inductor and the capacitor. This inductor and the capacitor which stores the energy, but what is the behavior of the inductor and what is the behavior of the capacitor means in the inductor, it will be opposes the sudden change of the current is nothing but the inductor. And the main behavior of this inductor is it opposes the sudden change of current. So, and that means the energy stored in the inductor will be the magnetic energy, and the what is the letter we have taken is the L, and the unit of the inductor will be Henry. And we take the capacitor. Under the capacitor, so capacitor means the behavior of the capacitor means it opposes the sudden change of voltage. It opposes the sudden change of voltage. So that means it stores the energy in the form of the electric field. So here the capacitor, we taken the word with the C, and the ohm we have taken the what is the unit of this capacitor will be farad. This about the resistor, inductor and capacitor. The main thing you have to observe that in the resistor it dissipates energy in the form of the heat, but in the inductor and capacitor it stores energy. But in the what is the main behavior of the inductor must be there? Inductor it opposes the sudden change of current, but in capacitor it opposes the sudden change of voltage. These are the different types of the elements in the. So these are the symbols of the resistor, and this is the symbol of the inductor and capacitor. For resistor there is the ohm, and inductor it is the Henry, and capacitor it is farad. So these are general sources are voltage sources and current source. Under the voltage sources there is the ideal voltage practical, and ideal current source and practical current source. So here we observe that what are the symbols of this there. There is the active elements and passive elements, or we see resistor, inductor and capacitor. Here we observe that there is A and C are the independent sources, and B and C are the dependent sources. The symbol of, you observe the symbols, the independent sources it will be the circles. We observe the independent sources will be in the form of the circle. So the independent sources means when you observe this, there is it does not depend upon, it does not control, one source does not control to the another source. But when you observe the dependent sources, the symbol is like that. That means one control, the dependent source is which will be the source, it is controlled by another source. That means here there are four types. I am discussing VCVS. That means voltage control voltage source. One voltage will be controlled to the another source. CCVS, current control voltage source. One current will be controlled to voltage source. VCCS, voltage control current source. CCCS, current control current source. That means one will be current control to the another. And when is we independent sources, it does not, it is in the independent point of view. It does not depend on another sources. So these are the basic difference of this elements. So in this session, we discuss about the what about the so different sources must be there, active elements and the passive elements must be there, and what are the types of elements must be there under the dependent sources and independent sources, active elements and positive elements must be there, and and what are the different next class we discuss about the what is linear, non-linear and the lumped and distributive elements must be there.